Hi, geometry. Yeah, you see all the answers on here because I just went through this whole video and I think I forgot to press record. So I'm ready to shout a couple four-letter expletives, but I'll get you through this. So I'll just turn the paper over, do a little bit at a time. Love and life. So maybe copy it down, pause it, or then listen to me. Like pause it, copy it down, then listen to me, and we'll see where it goes. So find the area of each polygon or circle. Okay, so we have a regular triangle. It's an equilateral with a side length 9. So what's nice about an equilateral triangle, it's a 60, 60, 60. But when I drop an altitude here, I have a special triangle, 30, 60, 90. And we know the side length is 9. So remember the formula, x, 2x, x squared root of 3. If 2x equals 9, divide both sides by 2, x equals 9 halves, or 4.5. And this will become, the height is 9 halves squared root of 3. So, area of a triangle is 1/2 base times height. So you have 1/2. The whole base, not the little part, the whole base is 9 times your height. 9 halves squared root of 3. 9 times 9 is 81. 2 times 2 is 4. We have square root of 3 inches squared. So there's your exact answer. If I actually divide that out and multiply by square root of 3, I'll have my decimal value. Approximate. Alright, how about a circle? But this one's a little different. And there's not a lot of space here, so I apologize. The circumference is given. So the circumference is given, we have to solve for r, because we need that for the formula for area. So circumference is 2 pi r. 30 is the circumference equals 2 pi r. Divide both sides by 2 pi to get that r by itself. So 30 divided by 2 pi is approximately 4.77. Now this is an approximate. This is the exact value for r. In pre-calculus, I would use this. So area is equal to pi r squared. So again, in calculus, I would put the 30 over 2 pi quantity squared and work it from there. But otherwise, you can just put in the values. I get about 71.48. Don't forget to put the units, meters squared. Right triangle. Here we go. I wish I would have put a trigonometric one in here, but Pythagorean theorem is okay. You have a right triangle. The hypotenuse is 12, and the side length is 6. So in order to find the area of a right triangle, you need 1/2 base times height. So I have to find this h. So using Pythagorean theorem, 6 squared plus h squared equals 12 squared. 6 squared is 36. 12 squared is 144. Subtract the 36 on both sides and take the square root. So you get square root of 108. And I know I'm going through this fast, so you're going to have to pause it and write these down. Area of a right triangle is 1/2 base times height. So I have 1/2. Your base is 6. Your height is square root of 108. Put that all in the calculator. Is about 31.177 centimeters squared. Now this problem is interesting because I had a different answer when I originally did it. I need to get x by itself. Now I'm going to cover up this side. I have x times all of that. So one way of getting rid of x is multiply by the reciprocal. So I'm going to take this side times 12 over all of that, because 12 is on the bottom, now it's on the top. Okay, so here I go. Look at this. This square root of 3 cancel with this one. And then square root of 3 times square root of 3 is 3. Remember, I have to square both of those. 2 times 2 is 4. 4 times 3 is 12. This cancels with the 12. What do I have left? Good old 15. Okay. Volume of a pyramid and a cone. Look at these formulas. And guess what? It's the same thing. 1/3 big B times h. Just specifically for a cone, big B, the area of the base is a circle, pi r squared. So what's neat about this is whether it's for the pyramid or the cone, if you fill this up 3 times, it will fill up a cylinder with the same radius and the same height. Same with this. If you fill this pyramid up 3 times with water, it'll fill up the prism with the same base and the same height. So 1/3 big B times h. Volume of solids. So I've got one of each. Not really sure why I wrote in red. 1/3 big B times h. I replace big B with pi r squared, because remember that's the area of a circle, times h. So I have 1/3 pi. The r is 5.7 squared, times your height is 12. Put it on the calculator, you get about 408.28 centimeters squared. Sorry, centimeters cubed, it's volume. Pyramid. 1/3 big B times h. Big B is a rectangle. It's 8 by 7 times your height. Put that all in the calculator. Please double check these for me too. 205.33 centimeters cubed. video is going a lot faster because everything's already written down, but we can do this. Alright, real life problem. The Pyramid of the Sun in Teotihuacan, Mexico. I have no idea if I pronounced that correctly, but it's a regular square pyramid. So it's not a rectangle on the bottom, it's an actual square with the height of 63 and the volume of 970,725 meters cubed. Find the side length. So 1/3 big B times H. So I have the volume I substituted in, 1/3. Now big B, the area of the base, it's a square. So x times 63. Now you see this 21 here because 1/3 of 63 is 21. I'm going to divide both sides by 21. You'll get x squared by itself. It's coming out really nice. Then take the square root and look at that. It's just, I find this amazing. If this is really true, I'm not sure how rounded that it is, and how are they able to figure this out back in those days. I don't know what year this was built, but it's still impressive that it came out kind of nice. I'm sure there's some serious rounding issues going on. How about this one? This one is using trigonometry, so here's a problem I do like. Find the volume of the right cone using trigonometry. Well, the problem is we don't know what r is. I'll put a question mark. Okay. So we know the height is 11 and this angle is 70. So according to this angle, opposite over adjacent. That's tangent. So tangent of 70 is opposite, which is 11, over adjacent. I put tangent of 70 over 1, and I'm going to cross multiply. 1 times 11 is 11. Then r times tangent of 70 is r times tangent of 70. I want r by itself, so I'm going to divide both sides by tangent of 70. 11 divided by tangent of 70 is about 4. Now a lot of students want to stop right there, but be careful. I need to find the volume. All I did was find the r. So 1/3 big B times h. So I 1/3 pi. Pi is part of big B. R is 4 squared times h, which is 11. Put it on the calculator. I get about 184.31 centimeters cubed. Right? Ooh, composite solids. Here we go. First, I want to find the volume of the box in the bottom. It's not completely a cube because the height's a little bit longer. And the volume of like the roof part, which is more pyramidal, I don't know. Here we go. So 4 by 4 by 5, it's 80. Because 4 times 4 is 16 times 5 is 80 inches cubed. Now the pyramid, 1/3 big B, so it's area of the base, which is 4 by 4. Okay, so we're using this 4 by 4. I don't want to confuse you. By 6. So 4 by 4 is 16 times 6, and then, well, here, let's do this. 1/3 of 6 is 2. 2 times 16 is 32 inches cubed. So what do I do with those two numbers? Add them up. 80 plus 32 is 112 inches cubed. Now this one, I'm going to do slightly different. I added these two volumes up, but this one, I'm going to find the volume of the whole cube, and I'm going to take away the volume of the cone. So the volume of the cube, this is an actual cube, 6 by 6 by 6. Multiply them out, you get 216. Now the cone is 1/3 pi r squared. Uh-oh, I have an issue here, don't I? Because I have 4 squared here. Why do I have 4 squared? What is r supposed to be? 2. 2 squared times how high it is. From here to here, it's still 6. And I have the right answer because I copied down my other page. I just mistakenly put a 4 here, so that's a 2. So 1/3 pi 2 squared times 6. 1/3 of 6 is 2. 2 times 2 times 2 is 8 pi, which is about 25.13. Take those two values, subtract them, you get about 190. Alright, last but not least, you are making coffee using a cone-shaped filter. It takes about 14 minutes to brew coffee. Find the flow rate. Okay, so it's like your rate of change of the coffee in cubic inches per minute. So we want to find out how much coffee is coming out of that little point per minute. So let's find the whole volume first. 1/3 pi r squared h. So the r is 3 and the height is 3.5. I think this is kind of big. I'm not really sure what the size of a coffee filter is. When you put all that in, you get about 32.39867 inches cubed. Well, I want the flow rate. This is how much you have in a total of 14 minutes. So if I take our volume and divide by 14, you get about 2.36 inches cubed per minute. So that's our flow rate. Now what's interesting is your flow rate can change depending on how high you are from the bottom of the cone point. Okay, in calculus you'll find those different rates of change. They call them related rates problems. So students dread them, but again, there's patterns. Here's our assignment and our Common Core standard, and this is the same standard as last section, but now we hit up the pyramids and cones. So everybody have a nice evening, and hopefully I'll crank out the last video of the chapter.